In this video, we'll discuss the construction and working of a lead acid cell. So we begin by taking a plastic container, we fill it up with H2SO4, dilute H2SO4. This is called the electrolyte of the cell. We take two more blocks, one block of lead dioxide and one block of lead. These are called the electrodes of the cell. Great. Now, the lead dioxide block, the moment you dip it into H2SO4, it starts reacting with H2SO4 and it starts losing electrons. Whereas the lead block also reacts with dilute H2SO4, but it gains electrons. Let's see how all of this functions. So we have positive and negative charges here, okay, and in the lead electrode as well. Great. Now, don't you think these electrons in from the lead dioxide block will start moving into the electrolyte, right? Because it wants to lose electrons. Amazing. Now, don't you think that the lead block will try to gain electrons and try to pull these electrons into itself? Great. Now, what happens because of this is that this lead electrode has now become negatively charged, right? And this lead dioxide electrode has become positively charged. And so we give them these names as well. Call this the positive electrode and we call this the negative electrode. Great. Now, because this is negatively charged and this is positively charged, don't you think because they're separated, there would be a potential difference between both these electrodes? Well, that's exactly what happens. We have a potential difference of 2 volts between the electrodes. Great. Now, don't you think if there's an excess of electrons here and there's a lack of electrons here? So, a lot of electrons repelling each other, and there's a lot of positive charges here, right? An excess of positive charges. Don't you think these electrons would happily run back to the positive electrode if they were given a chance, right? So, if we connect a wire, that's like giving these electrons a free ticket to run back and go and get attracted and run back to the positive electrode, right? And that's what happens. These electrons start running back to the positive electrode and they go back home. Great. Now, do you think this reaction will stop here? Obviously not. Why? Well, because the lead dioxide is going to react again with dilute H2SO4, right? And these electrons are going to move into the electrolyte once again. And then the lead electrode is going to pull them into itself, right? And then because we have this wire connecting the negative and the positive electrodes, these electrons are going to want to run back to the lead dioxide block, right? Does it stop here now? Obviously not. This process is going to repeat itself once more. The electrons from the lead dioxide block are going to move into the electrolyte once again. And they're going to move to the lead electrode once again and then make their way back home, right? This is going to happen over and over and over again. And this entire process is going to look like this, right? Where the electrons start from the lead dioxide block, go to the electrolyte, move to the lead electrode, and then make their way back home, right? What if I connected a fan in between? Don't you think this fan will start running? Well, what's happening here is that the electrons are running back from the negative electrode to the positive electrode, and in the process, they encounter the fan. So they go through the fan motor and make the fan turn, right? If you connected a bulb, that would light up. Okay, so that's how a lead acid cell works. Great. Now let's move on and let's go and discuss how a lead acid battery works. This is how a lead acid battery looks. Now, in the previous video, you saw that a battery is nothing but a collection of cells, right? Connected together. So let's say we took maybe 4 in this case, we took 4 lead acid cells, and let's say we connect them in series to each other. So basically the negative electrode from this cell is connected to the positive electrode of this cell, the negative electrode of this cell to the positive electrode of the next one, and so on, right? Okay, let's say we take a wire from the first cell's positive electrode and the last cell's negative electrode. This end is going to be called the positive terminal of the battery, and this end is going to be called the negative terminal of the battery. Great. Now, if I connect a fan to the positive and negative terminals of the battery, the fan starts running, right? Great. Now, this is how a lead acid battery works. This entire box will have a lot of cells within them. Okay, and all of them would be connected to each other, and this battery will have two terminals, a positive terminal and a negative terminal. Let me show that to you in detail. So if we zoomed in, this is the negative terminal, it says so, and this is the positive terminal, it says so, right? So if you want to run any appliance, run anything from the battery, connect two wires, one from the positive, one from the negative, to the appliance. Okay, great. Let's, before we close this video, let's just go through a few applications of the lead acid battery. The lead acid battery is used in cars, in trucks, in bikes. It's used to start up the engine of a vehicle. Okay, the lead acid battery is used for power backup applications as well. It's used as inverter batteries in industries, at homes, in a lot of places like that. Okay, it's also used in cell phone towers. When the main power gets cut, you immediately want to power up your cell phone tower, and these lead acid batteries are useful for power backup. They're also used to store energy, especially in solar power setups where you use solar power and you charge these batteries. And then in the night, when you don't have the sun, you use the batteries to power different appliances. That's it for this video. Thanks for watching.